Sure.
So for the homework,
Mhm.
I was just thinking about it now. I didn't. So I did the table for the depreciation thing. I was thinking about you probably want the table, yeah.
Yes. Yeah.
I don't want to write it out in hand. Just take a picture of it and submit it as a PDF.
Of course. Yeah, that's fine.
I was like,
Yeah.
okay, all right, thank you.
Mhm.
All right, it's 1 o'clock. Let's go and get started. All right, good afternoon, everyone. How's everyone doing today? Good, good. All right, week 9. So we're very close. We're very, very close to spring break. So we have this week and then next week, and then we're off for a week. So hang in there for a bit longer. All right, so the plan for today is we're going to be doing more on our replacement analysis. So I think we ended last time right before we were about to do an example. So we'll do that example today and then kind of continue on with that. Either today might be the last day of replacement analysis, or we might finish it up last step on Thursday. We'll see. Okay. All right, so just a reminder, homework, the next homework is due, homework 4. So that's due this Wednesday. So make sure you guys are working on that. The tax problems do take a while, and so they can be a little bit tedious if you're not prepared. So, you want to make sure you give yourself enough time for that. Especially the very last one. The very last one definitely is it's a doozy. And in fact, I have to go back and check my own answers to make sure I did it correctly too. So yeah, we'll go with that. Okay. All right, I think that's it for my announcements. Not much in the way of announcements today. Are there any questions I can answer before we get started? Okay. All right, so let's go ahead and continue where we left off. And so what we were doing last time was called replacement analysis. Replacement analysis in an economic life. Okay. So the whole idea with this unit is determining when is the best time to buy a replacement for an existing asset. So buying replacement is something that happens a lot in practice, right? So if you run any kind of engineering firm, you'll be utilizing large pieces of equipment, large assets that you're going to keep over many years. Oftentimes, these pieces of equipment they're able to be used for a long period of time, but oftentimes, what's most economically viable or the best thing to do is to kind of only own the asset for a certain amount of time, right? And we call that the economic life. And what we are looking to minimize here is we want to minimize the yearly cost of ownership, right? So if we take account all the costs that's associated with owning and maintaining an asset, things like the initial costs, the maintenance costs, any overhaul costs, and we kind of spread that out over its years of life, right? Using interest rates and things like that. You want to minimize this yearly cost of ownership, right? Which remember last time we said is an EUAC, right? Or in other words, an equivalent uniform annual cost. Right? So what this means is that for replacement analysis, annual cash flow analysis is going to be our bread and butter here. That's what's going to drive everything. Another way that you can look at this, and another way that we kind of, to motivate the fact that we're using annual cash flow analysis is that, we're doing comparisons on the same asset for different years of ownership, right? And so in all these cases, our product lives are different. And if there's one thing that we learned in annual cash flow analysis is that, it really shines in those situations because we don't have to, find the least common multiple and things like that. Okay. So that's kind of another reason why we use annual cash flow. Okay, so let's just jump right into an example then to kind of get the ball rolling today. Okay, so in this example, let's say that we are considering a machine with an initial cost of $18,000. The maintenance on this machine costs $900 in the first year. Okay. And this maintenance is set to increase by $500 each year after that. In this problem, we're also going to consider the market value. Okay. So there is going to be a salvage cost that we need to account for as well. And generally speaking, the longer you keep an asset, the more the market value is going to decrease, right? That's the whole idea with depreciation. So the market value for the asset is going to start at $5,000. Okay. And so if we sell the machine at the end of year one, then it's going to be worth $5,000. Okay. But the longer we keep it, the market value for the machine is going to decrease by 10% each year. Okay. Another thing that we're going to consider is an overhaul cost. Okay, so our overhaul cost is going to be $3,240. Remember, overhaul costs are usually kind of one-time or irregular costs that occur during the life cycle of a machine. Usually they represent some kind of major maintenance that has to occur at some point. Okay. And so this overhaul cost is going to occur at the end of the 6th year. And so if we keep the asset for more than 6 years, then we're going to pay this overhaul cost. But if we salvage it beforehand, if we sell off the machine before that 6th year, then it becomes someone else's problem. Someone else has to pay that. So we don't have to pay it then. Okay. All right. The useful life of this machine is 10 years. And we're going to assume an interest rate of 8%. Okay. So based on this information, let's compute the economic life of this machine, also its minimum EUAC. And those two things are tied together. All right, so that's the example that we're working on now. Okay. So for all of these economic life calculations, you're basically going to treat it as an annual cash flow type problem. So you're going to take each of the cash flows in the problem and convert it to a uniform series. Okay. With some caveats, of course, right? So there's going to be certain special cases with like overhaul costs and the salvage values, but generally that's what we want to do. Okay? So what I'm going to do first is I'm going to list out all of the cash flows that are given in the problem, and I'm going to write an expression that converts that to a uniform series. Okay. Okay, so let's start with the initial cost. And so our initial cost is $18,000. Okay. Initial cost is a cash flow that's always in the present form, right? So to convert a cash flow from the present form to a uniform series, we need to multiply by conversion factor A over P. Our interest rate here is 8%. And we're going to apply this for different amounts of time, which is n, right? Remember, this n here is going to represent the amount of time or the length of ownership. Okay. So what we're eventually going to do is we're going to form our table, our economic life table, and plug in different values of n and compute what that initial cost would be for different values of n. Okay. All right, next we have the maintenance costs. So there's two aspects of the maintenance costs. I'm just going to lump both of them together into one just to save some space, right? So from the problem, we saw that our maintenance cost is going to start at $900 per year in the first year, okay? So that $900 is already a uniform series. Okay, so we can just add start with 900 there. And then what the problem also says is that this maintenance is going to increase by $500 per year. Okay? So we're going to have 900 plus 500. And we need to convert that gradient into a uniform series. So it's going to be A over G, 8%, and N. Okay. Next, we have the salvage value, or as the problem described it, is the market value. So those two are interchangeable, right? The market value is just kind of the amount that you can sell the asset for at a given time. And the way that we've kind of defined that in this class is salvage value. Okay. Okay. So the salvage value, we're actually going to use a negative sign here. Because everything that we're considering as positive here are the costs, right? The initial costs, the maintenance costs. Because the salvage value is going to be a positive number, it needs to be opposite sign from cost. Okay. I know this is kind of reverse what we usually do. Usually for costs, we make negative, and for salvage values, we make positive, but you know, we're just flipping that in this problem. If you wanted to make all your initial costs and maintenance costs, all those are negative, that's fine too, you know, as long as you're kind of consistent with both. All right. So for the salvage value, we said that it starts at $5,000 for the first year, right? So if we sell this thing for at the end of the first year, we're at $5,000, but then each year after that, its price is going to reduce by 10%. Okay? So the way I'm going to represent that is I'm going to multiply this, okay, by 0.9. Okay? Because when something is reduced by 10%, that's the same thing as multiplying by 0.9, right? And then to represent the fact that this 10% is going to be taken off each year, I'm going to raise this 0.9 to the n minus 1 power. Okay. All right, so if you've never kind of seen this notation before, this is kind of a useful way to kind of do a compounding kind of 10% reduction each year, okay? Because if you plug in, so let's plug in n is equal to 1 into that, right? So if you have 0.9 raised to the 0th power, anything raised to the 0th power is just 1, right? And so if n is equal to 1 and we sell it at the end of year 1, then we get a salvage value of $5,000, which is exactly what we want, right? If we try plugging in n is equal to 2, and so we sell it at the end of the second year, that means that our price here is going to reduce by 10%, right? And so we have 0.9 raised to the 2 minus 1 power. 2 minus 1 is 1. And so we have $5,000 times 0.9, which is 4,500, which is 10% less than that. Okay. So this part right here represents the fact that our value decreases by 10% each year. All right, so that's our sales price, but we still have to convert this to a uniform series, right? So a salvage value always takes place at the very end of the cash flow diagram, right? So it is a future sum that occurs at the end. And so to convert to a uniform series, all we have to do is just apply an A over F conversion factor, 8%, and then the same N that we used up there. All right, and then finally we have the overhaul cost. So for the overhaul cost, we have two different cases here, right? And so if we sell the asset before the overhaul takes place, right? And so remember the overhaul is scheduled to take place during the 6th year, okay? And so if we sell the machine before that, then we don't pay any overhaul costs at all. In other words, this is if n is less than 6, okay? So if n is less than 6, then we don't pay anything. We just, we don't worry. If we keep the asset for 6 years or beyond, then we pay the 3,240. But then we have to spread this out over the time period, right? Because we have to convert this to a uniform series. Okay. But remember, with overhaul costs always happen at a fixed year, right? They're different than the salvage cost. So the salvage value it always happens at the very end. But this 3,240 is always going to be occurring in year 6. And so to spread it out over an unspecified time frame, then we have to do a non-standard conversion. Okay, so there are multiple different ways that you can do this. So what I like to do is I usually like to take this overhaul cost, convert it back to the present day. Okay, so you have P over F, 8% and 6. Okay, we can always use 6. We can always use 6 there because we know that this isn't occurring in the 6th year. Okay. And then once we've converted this 3,240 to the present day, we can then spread it out and convert it to a uniform series. Right? We have A over P, 8%, and N. Okay. All right, so we have basically a pretty standard kind of non-standard conversion. So what this does here is it converts the 3,240 to present day. Okay. And then this part right here converts that present day sum to a uniform series. All right, so those are all of our conversions there, right? So we've basically taken all the cash flows. There's quite a lot in this problem. We have 4 different types of cash flows, and we've converted each of them to, or we've at least come up with an expression for them to convert them to a uniform series. Okay. Any questions on how we did any of these conversions here? Okay. All right. So let's go ahead and let's go ahead and make our table. All right, so we'll call this the economic life table. And I'm going to make a column for each of the different cash flows that we had up there, right? So we're going to have 4 columns, one for the initial cost, one for the maintenance, one for the salvage value, one for the overhaul. And then we're also going to make a column for the year and a column for the total EUAC. All right, so we have one column for the year. Next column will be the initial cost. We have another column for the maintenance costs. We have another column for the salvage value. We have another column for the overhaul costs. And then finally, our last column will be the EUAC, which is what we're going to get by summing up everything in the row. Okay. All right, so we're going to evaluate this for 10 years. Because what the problem told us is that the useful life of this machine is 10 years. So we can keep it for up to 10 years, but likely we're going to keep it for less than that just because of the all the time here. Okay. Okay. So let's go ahead and list these out. So yeah, I guess before we start computing things, we know that in this problem we have a big overhaul cost that's occurring in year 6, right? And so intuitively, you would think that we would try to hang on to the machine until that happens, and then try to sell it to someone so that it can be someone else's problem, right? And so intuitively, you would think that keeping it up to 5 years would be best, because then we avoid that kind of large scale maintenance that has to occur. But we'll see. Let's run the numbers and let's see. Okay, so let's start with the initial cost column. So the initial cost column is pretty straightforward. So we're going to take our 18,000 and then just simply multiply it by our A over P factor. Okay. Okay, so let's go ahead and do that. Okay, so first year is going to be 19,440. Then we have 10,000, 94.40, and 6,984. And 5,434, 4,509, 3,893 and 40 cents. Okay. So that's our first column for the initial cost, right? And remember, the way I got all these numbers here was I took our expression for the initial cost up here, and I just plugged in different values of n. So n is equal to 1, n is equal to 2, 3, 4, 5, and so on and so forth. Okay. So So that's how I got all the different numbers here. Okay. All right, so you can see here from the trend here that our initial cost starts very high, but then the longer we keep it, we keep it up to 10 years, then that initial cost gets spread out over all the different years, right? And so our yearly cost of ownership just from the initial cost goes down. Okay. So the way I like to think about it is that the longer you keep an asset, you spread that initial cost over many, many more years. Okay. Hence this goes down. Okay, let's look at the maintenance cost now. So our maintenance had two components, and so we had our uniform series part, flat 900, and then we had the growth part, which is the 500 from there. Okay, so we're going to start here. Year one, it's going to be 900. Okay. Second year is 1140 and 50 cents. Next, 1374.50. So you can see that the maintenance costs are going up, right? Which makes sense. Generally, the older an asset gets, the more money it takes to maintain, right? Just because things start to break down, you have to replace more parts, and so on. Remember that everything here is converted to an EUAC, right? So everything is converted to a uniform series. Right? So even though our maintenance costs are growing by $500 per year flat, you can see here that the growth of the EUAC is not $500 because we're spreading out that increase over a longer period of time. Okay, next we have the salvage value. So the salvage value will be a minus 5,000, okay, to start. And then from there, we have kind of a double whammy effect. And so on the one hand, the market value for our machine is dropping by 10% per year. But also what we're doing is we're taking that salvage value and spreading it out over all the years of ownership as well. Okay. So you can see here that this is actually going to decrease quite rapidly. So we're going to start at 5,000. Then second year is going to be minus 2163, 60. It's minus 1, 2, 7, 40. Minus 808, 83. Okay. So that's our salvage value column, right? So it starts off pretty big, but then it decreases very rapidly, right? Not only because the sales value is decreasing, but also we're spreading it out over a longer period of time as well. Okay. All right. And so finally, we have the overhaul costs, right? So remember the overhaul costs, we have two different cases here, right? So if we sell the machine before year 6, then we don't pay anything at all, right? So let's go ahead and fill that in. And so in years 1, 2, 3, 4, and 5, we're gonna have 0 overhaul costs for those years, okay? Because it hadn't happened yet. But if we keep it in the 6th year and beyond, then the overhaul costs are going to be there. So in year 6, we take that $3,240 of overhaul, we spread it out over many years, okay? And we end up with a uniform series of 441.65. Then next, we have 392.24. And 355.28. And 326.90. And 304. All right, so now that we're done with everything, we can just add across the row here, right? So to get the EUAC, we're gonna take each entry in a row minus the year, of course. We don't have to add the year, and we just add everything together. Okay. So if we keep it for 1 year, right? The combined cost to keep it for that 1 year is going to be 15340. Okay. So I got that number by taking 19,440, adding 900, and then subtracting 5,000 from that for the salvage value. Okay. All right, we do it for year 2. So this is if we kept the machine for 2 years. We get 9,071 and 30 cents. Okay. So just by keeping it for 2 years, right? Even though our salvage value went down by 10%, you know, it was a big decrease in our initial cost, right? Because we spread it out over 2 years. And so you can see our EUAC here is a lot smaller than that. All right, let's keep doing this. Okay. So those are the EUACs if we kept the machine for 2 years, for 3 years, for 4 years, and for 5 years. Okay. All right, so now comes the fated 6th year. So this is the first year where the overhaul costs kick in. Okay. And so you can see that our yearly cost of ownership actually went up in that case, right? Because of the overhaul. Right. So you may be tempted to stop here, right? So you may be tempted to say like, all right, you know, we went from year 5 to year 6, our yearly cost of ownership went up. Okay. And if that's the case, then we should only keep the machine for 5 years, right? Because that's what minimizes our cost of ownership. All right, but there's a reason, you know, we wrote this table out for all 10 years is because, you know, maybe things get better later on. So let's see. And so if we keep it for 7 years, our yearly cost of ownership is 5,799. Okay. For 8 years, our yearly cost of ownership is 5,712. Okay. So you can see already that in the 8th year, our yearly cost of ownership is actually less than the 5th year, right? So our new minimum here is 5,712. Okay. Let's keep going. If we keep the machine for 9 years, then our yearly cost of ownership is 5,681. So that's even less. So this is now our new minimum here. And then finally for 10 years, then our yearly cost of ownership is $5,689. Okay. So slightly higher than our okay. But based on these numbers here, we can conclude that the economic life for this machine is 9 years. Okay. And our minimum cost of ownership, our minimum yearly cost of ownership is $5,681. Okay. Right. So this was a good example. So this kind of shows you how to deal with kind of our four main types of cash flows here. So it showed us how to deal with our initial costs. It showed us how to deal with a salvage value and increasing maintenance costs and overhaul costs as well. Not only that, but it kind of gave us a surprising result. And so, if you just looked at the numbers for this, right? And so the fact that the overhaul cost didn't kick in until the 6th year, you would think that, let's avoid that overhaul cost. Let's sell the machine before it, right? And even though there was a small spike, right? So even though there was a small increase of the 6th year, because of that overhaul, if we kept it for longer after that, then the EUAC kept continuing to decrease, okay? And so we end up with our answer here, which is 9 years and an EUAC of 5,680. All right, any questions on this example here? Okay. All right. So that's economic life. And so, most problems are going to be kind of just variations of this, just different kinds of different numbers, of course, different kinds of costs. Maybe sometimes we'll have multiple overhaul costs. And so that's something to take into account. Okay. Let's see how this fits into replacement analysis. Okay. So the analysis that we just performed, or the economic life analysis, that's typically done, or that's typically performed before you buy a new asset. Okay? Okay. And so it's something that you determine, before something's even bought, right? And so, let's say that you're shopping in a catalog, right? You see all the numbers for a particular machine. You can run this analysis to determine, how long would you keep the machine if you bought it. Okay? So of course that's useful, right? And so that's always useful to know, just so that you have an idea of kind of how long to keep a particular asset. Okay. But oftentimes, you're not just kind of buying a machine just from scratch, right? You actually have an existing machine that you're considering replacing. Okay. Okay. So for an existing asset, we do a little bit of a different analysis. Okay? And so the analysis that we compute is something called the marginal cost of ownership. Okay? And what marginal cost basically means that if you were to keep your asset for just one additional year, right, how much would that cost you? Okay? Because usually if you have an existing asset, right, You know how much it's going to cost you in maintenance per year, right? You also have kind of an idea of what the difference in market value is going to be if you kept it for one more year, okay? And so to do a full kind of replacement analysis, you actually need to do both of these together, right? So on the one hand, you need to consider replacements, right? And so you need to find out what the economic life and the minimum EUAC would be for the replacement, okay? So a full okay. And so on the one hand, you need to do an economic life analysis of a potential new asset, or in other words, of what the replacement would be if you were to replacement. And so through this, you're going to obtain the minimum EUAC the minimum EUAC of the new asset. And what you're going to be comparing this to is the marginal cost of ownership for the existing asset. Okay. And so the main thing that you're going to see is that if, depending on the value of these two things, right? If the minimum EUAC of a new asset is less than the marginal cost of an existing asset, then this is the best time to replace. So if this is true, if the minimum EUAC of a new asset is less than the marginal cost of owning an existing asset, then it's time to perform a replacement. If it's not, if it costs less money to maintain your current asset, and so the marginal cost of ownership is less than the minimum EUAC of a new one, then you don't replace. Then you kind of keep your existing. Okay? So this is kind of the essence of replacement analysis, right? And kind of when you say it out loud, when you think about it in that terms, it makes a lot of sense, right? Because the minimum EUAC that we compute from economic life, that's the yearly cost of ownership, averaged over each year for the new asset. Okay. And if that costs less than what it would take to maintain your current asset, then it's time to throw your existing asset out, buy the replacement, and then go on with that. Okay. Now I will say that what the computations that we're doing in this section Just to kind of keep it, time efficient. I didn't want to spend too much time in the class on this. We're not considering things like, a newer asset will have things like better features that maybe be able to drive new revenue in or make your workflow more efficient. And so those are things that need to be accounted for. So we're doing kind of a very basic kind of version of this replacement analysis where we only consider the costs. Okay. But in reality, if you were to kind of do this in practice, you would have to take those increased capabilities and efficiencies into account. Okay. And that's certainly going to affect your calculations. But for now, we're just going to look at just the cost side of things. Because honestly, when a business is looking to replace one of its assets, that's probably the main thing that they're looking at. They're looking to buy a machine that has either increased capabilities, increased efficiency, right? And it's not just the increasing maintenance cost, and it's not just the initial cost. But what I wanted to show you in this unit here was to kind of just give you a framework for doing this. Because incorporating that it's not the hardest thing in the world. It's just this semester was kind of packed at this point, so we just didn't have time. Okay. But I did want to make note of that just in case that, if you want to apply this for your car, if you want to apply this, maybe, you have your own business or something like that, you would need to make sure that you account for that. All right, any questions on this so far? Okay, so let's talk about how to compute the marginal cost. All right. So to keep an existing asset running, right, we have to pay our usual kind of upkeep and maintenance costs. Okay. So that's pretty standard, we're used to that at this point. But there's another kind of cost that's associated with this that we've kind of implied today, but we haven't kind of explicitly done this as well. Okay. And I think the best way to describe it is an opportunity cost, right? So it's a cost that you incur for not acting at the current time. Okay. And that has to do with the market value, right? And so we've talked about before that the longer you keep an asset, its market value goes down, right? And so if you choose not to sell it today, there's an opportunity cost of, when you sell it in the future, it's going to be worth less than it is today. Okay. Okay. The reason I'm kind of describing it as an opportunity cost, even though it's not actually a cost, right? And so, you don't actually pay someone to not sell your machine, right? But if you think about the fact that, if you sell, let's say your car, right? So let's say that you use your car for one more year, you sell it a year from now, right? Of course, your car is going to be worth less a year from now than it is today, right? And so that difference in sale value, that difference in market value between, whether you sold a car today or you sold it in the future, right? That's essentially a cost, right? That's a cost that you have to incur. Okay, so I'm going to model it actually like this. And so I'm going to use kind of a very simple cash flow diagram. Okay. So our cash flow diagram is going to have two points in it. Okay. And so on the first node here, we have time 0. And so time 0, that's going to be the present day. And then our next node is going to be 1. So that's going to be 1 year from now. Okay. If you choose not to sell today, right, it's almost like you're kind of paying out the current salvage value, the current market value. Right? Okay, so we're going to label that as kind of like an opportunity cost, right? So if you choose not to sell today, okay, so if you choose not to sell today, it's basically the same thing as taking the current market value and dropping it as a cost. Okay. So the size or the length of this down arrow here is the current market value of the car or the machine. I keep using cars. Car is the best example of this. All right. But then, let's say that you choose to sell it a year from now, right? So you choose to sell it 1 year from now. And so we have an up arrow there. And so we sell it a year from now, that's going to be a positive cash flow. And it's going to be a positive cash flow in the amount of the future market value. Okay. And so this arrow, the size of this arrow is going to be whatever the future market value is going to be, right? A year from now. We may not know exactly what it's going to be, but we can at least, estimate it based on kind of similar machines and so on. Okay. All right. So this cash flow diagram that I drew here, it kind of represents the situation of, you chose to keep your asset, right? So you chose to keep it for 1 more year, you're not selling it. And so you're going to incur this, this cost here, right? Because if we compare these two values, right, almost certainly the future market value it's going to be less than the current market. And so you're forfeiting kind of a larger amount of sum today, and you're going to be kind of selling it at a lower price in the future. Okay. That's generally how it goes. Of course, you do have assets that do increase in value over time, that actually appreciate in value, but we're not considering those. We're only considering kind of the depreciating assets. Okay. All right. In addition to these two, right? And so if you chose to keep your asset for one more year, the other thing that you also pay are its operational costs, so all the maintenance and upkeep costs. And so we can label those as another arrow down here for operation cost. And that depends on the machine and whatnot. Okay. So this kind of small cash flow diagram here kind of represents kind of that little kind of micro situation where, you know, if you take your asset and you keep it for one more year, right? You keep your asset for one more year, you pay for the operational cost to maintain it, but you also pay the opportunity cost of not selling it at its current value. Okay. And so if we take this kind of simple cash flow diagram and we convert it, right? And so if we take this and convert it to a single lump sum at the end of year one, okay, we convert to a single sum at the end of year one, what that sum is going to represent is the marginal cost of ownership for that asset. Okay, which is exactly what we're looking for, right? And so we kind of came into this section kind of, you know, trying to see if we can come up with a formula for the marginal cost of ownership. Okay. All right, so let's go ahead and do that. And since it's a fairly simple cash flow diagram here, we don't really need the compound interest tables. So we can just do it straight from the formula. Okay. So our marginal cost, or the MC, is equal to the old salvage value. So we'll call this salvage, or I say the current salvage value, salvage current. Okay. We're going to take this cash flow and fast forward it 1 year. And so we're going to multiply by 1 plus I. Okay. Minus the salvage future salvage value. And notice I'm flipping the signs here. So this is the marginal costs, right? So the actual costs are going to be positive and all the benefits are going to be negative. Okay? Plus operational cost. All right, any questions on that before we do a quick example? Okay, so let's do an example to kind of see how this is done in practice. Okay? All right, so let's say that we have a piece of machinery at our company. And it has the following maintenance costs. So the maintenance cost for this existing piece of machinery was $2,000 in year one. Okay. And it will increase by $500 per year after that. This machine is also at risk for breaking down, right? So this is something a little bit new that we're incorporating here. Okay. So another thing that you can quantify in these marginal cost and economic life calculations is the fact that, you know, the longer you keep an asset, it's more likely to just spontaneously kind of break. Okay. And so we're going to quantify this in terms of dollars. Okay. And so these the breakdown risk that you'll see, you know, part of it has to do with the fact that, you know, if it breaks down, you have to either you know, close it down and put it in and deliver it for kind of a major maintenance. Okay. So you kind of think of it as like an overhaul cost, or more realistically, these are kind of be maybe like your deductible for an insurance. Okay. So if you, a lot of times, if you have a big piece of machinery, if you're an insurance company, it's going to be insured to some degree, right? And so if your machine breaks down, then there's a certain amount of deductible or a certain amount of kind of minimum payment you have to make to replace it. Okay. So, you know, this breakdown risk or this quantified can be kind of representing both of those things. Okay. So the breakdown risk will be $5,000 per year. Okay. For the first 3 years. And then each year after that, the breakdown risk cost will be $1,500, will increase by $1,500. Okay. Last thing that we're going to quantify here is the market value for this machine. All right, so I have a table here that kind of represents this. So this table here is going to list out the market value as a function of time. Okay. And so if we were to sell the machine at the end of year 1, then our market value would be $22,000. If we sell at the end of year 2, our market value is going to be $19,000. Year 3 is going to be $16,000. Year 4 is $13,000. Year 5 here is $10,000. If we sell at the end of year 6, it's worth $7,000. And year 7, worth $4,000. So the market value for this machine is just a very straightforward straight line depreciation, decreased by $10,000 per year, or $3,000 per year, excuse me. Okay. All right. And so if we assume, let's assume our interest rate here is 15%. Okay. Let's compute. Let's compute the marginal cost of ownership for keeping this machine around for several different years. Okay. So we have data on this machine for 7 years. So let's compute it for up to 7 years. Okay. Okay. Any questions on just the setup of the problem or kind of what we're looking for? Okay. All right. So the way we're going to do this is we're going to set up a table again. The marginal cost table is usually pretty, a little bit easier to do, okay? Just because of, just how it's designed, okay? So let's do it like this. So this is our marginal cost table. Okay. So, we're basically looking at this asset, as if it were kind of brand new. So let's say that our company just bought this asset and, we want to, see, how much it would cost each year for us to own. Okay. So let's make 7 rows, one for each of the years of ownership. Okay. Our first 2 columns here have to do with the salvage value. Okay. Okay. Salvage value, market value is the same thing. So the current salvage value is the current market value. Okay. Next is going to be the future salvage value. Okay. Next, we're going to have a column for the maintenance. Okay. Next, we have a column for the breakdown risk. Okay. Then our last column there is going to be our marginal cost. Okay, so let's do the first row, right? So the first row, the perspective that you're taking is that you're viewing the marginal cost from year 0, and you're going to see how much it's going to cost you to keep that machine from year 0 to year 1. Okay. So I think this is the most confusing part. It's kind of what to fill into for each of these columns for the salvage value. Okay. So for the current salvage value, this is the kind of the salvage value of the machine before the current period. Okay. So for instance, for that first row on the table, right? That first row on the table is for year 1. So that's assumed that we kept the machine for 1 year. Okay. And so based on that, right? If we look back at our table that we've been given in the problem here, we know that at the end of year 1, the market value for our machine is going to be $22,000. Okay. And so that $22,000 is actually going to go in the future salvage value column. Okay. Let me highlight that in another color. So this right here, the salvage value or the market value at the end. Okay. This is the salvage value at the end of the period under consideration. Okay. Okay. So that means that the current salvage value or the salvage value before year 1, right? That's going to be if we sold this machine before year 1 occurs, right? Which in this case would just be the initial cost. Okay? Okay. So if you don't have any information in the problem based on kind of what the initial salvage value would be, okay, at the start of year 0, basically, okay, then you can just assume that this is the initial cost. Okay. I think I forgot to give you the initial cost. The initial cost for this asset is $25,000. Okay. Sometimes it'll be given to you, like in the previous example, I think it was given to you kind of what the salvage value was at the very beginning. But if it's not given to you, you can just use the initial cost. Okay. Okay. Then we go to the maintenance costs. We know for that first year, that maintenance cost is going to be $2,000. And the breakdown risk was 5,000. Okay. All right. So our total operational costs. Okay, so both of these together, these are our operation costs. And so based on this information in the table, we can basically take everything here and plug it into our marginal cost equation up here, right? So we take our current salvage value, the value that's in the first column, we multiply by 1 plus I. We subtract the future salvage value, which is the value in the second column, okay? And then we add all of our operational costs together, okay? So that means for this first value right here, okay? The way that we're going to compute this is we're going to take 25,000 multiplied by 1 plus the interest rate, so 1 plus 0.15, okay? Minus the future salvage value of 22,000 plus 2,000 for the maintenance costs plus 5,000 for the breakdown risk. Okay? All right. And so if we do that, we plug into that formula, what we get is 13,750. Okay. All right. Any questions on how we got that number there? Okay, so let's go ahead and do this for the rest of the years as well. Okay, so year two. Okay, so at the beginning of year two, right? The beginning of year two is the end of year one, right? So the current salvage value at that point is $22,000. Okay, it's whatever the salvage value was at the end of year one. Okay, so you can see here that we've basically taken this number, just kind of copied it over there. Okay, then the new salvage value, if you were to sell it at the end of year two, this is $19,000. Okay. All right. And so if we put in the maintenance costs went up by 500. We do the breakdown risk, it's still 5,000. We add across, or we plug into the formula. We get our marginal cost of ownership for year two to be 13,800. Okay. Let's do the same thing for year three. So for year three, our current salvage value is 19,000. Okay. Our future salvage value here is 16,000. Maintenance is 3,000. Breakdown risk is 5,000. Okay, our marginal cost for year three is going to be 13,850. Okay. We're almost out of time, so I'm just going to kind of finish up this table really quickly. And so for year four, 16,000. New salvage value is 13,000. Maintenance cost is 3,500. Year four is when the breakdown risk is going to start to go up. Okay. And so our marginal cost of ownership is 15,400. Okay. Year six. Erase this line here. Okay. So those are all the numbers for this particular. Okay. So you can see as we keep the asset for longer and longer, not only because of the decreasing salvage value, but also because of the increasing maintenance costs and the breakdown risk is going up as well, it's going to be more and more expensive to maintain this machine year after year. Okay. And so when we come back on Thursday, we'll combine this analysis. We have another kind of economic life analysis that goes kind of in parallel to this, and we'll see when's the best time to replace this asset with. Okay. All right. Any questions on this before we head out for today? Okay. All right. So that's all we got for today. So we'll pick this up again on Thursday. So thank you guys again for coming today. Hope you guys have a good rest of your day, and we'll see you Thursday.
Hey, Professor.
Oh, someone.
Hello?
Oh, I heard someone.
I know it's like
Hang on.
That's me, Zach.
Hang on, Zaka. Let me turn up the volume. I hear you, but I can't really hear. Wait, say again?
No worries. I was doing the homework for the one that's due that's due tomorrow.
Yeah.
And I'm having difficulty with problem 2A and B. I think I might have been absent for those lectures.
I see. Do you want to send me your work over email? I think it's a little bit easier for me to look over that over email, just because it's a lot of kind of details. So if you send me over email, I'll take a look and I'll answer you.
Okay. I completed some of the work. The percent is a little off.
Yeah.
But I don't think it's right. I don't think I have it sorted properly. Should I send it to you right now?
Yeah, go ahead and send to me. Go ahead and send to me right now. Yeah.
Okay.
Wait a second. Hang on, let me try to change the speakers because it's really hard to hear you.
Sorry, I'm in the library right now. That's why it's a little
Wait, go ahead and
loud.
say it again.
I'll send over the picture of my work right now for number 2.
Okay, sounds good. Yeah, I'll take a look.
I'll let
take
you
a
know
look when I
once
get back
it's
to my office.
Okay, sounds good. And then what time is your office hours end today, or what start and end?
It ends at 3:30 today.
3:30. Okay. Is there any office hours afterwards, or do I have to wait until like tomorrow or day after?
So after today, the only other office hours is Thursday from 2:30 to 3:30.
2:30 is sorry.
2:30 to 3:30 on Thursday. So it's after the lectures for this class.
Shoot. Okay.
Yeah, if those times don't work for you, just send me an email and we can try to find a time to meet outside of that.
Okay. Because right now I have to go run an errand, so I won't be able to finish the homework until tomorrow afternoon.
Okay. Yeah, just go ahead and send me an email. Let's see if we can find a time to meet tomorrow then.
Yeah, sounds good.
Okay.
I'll send it over a little bit later.
Okay, sounds good.
Thank you.
Yep. Bye. What's up?
I'm struggling to get on the Zoom. For some reason, it says like proxy or something like this. I tried checking off my ad blockers, VPNs, everything, but it kept doing the same error.
I see.
I'm not sure if I can make it to every class.
Yeah.
Because I'm fasting right now.
Okay.
Is it okay if I just catch up with the YouTube videos?
That's fine. Yeah, that's fine. I mean, will you be able to make it for the exam after? So the exam's not until after spring break.
How many weeks ago? 3?
So it's not next week.
What date is it?
It's gonna be April 9th, I want to say. It's the first week. Actually, the first lecture we come back from spring break.
That might be like by the end. But I should be able to do it even
Okay.
if I'm passing. I'll start up before.
Okay, yeah, that's fine. But yeah, besides that, if you just watch the YouTube lecture.
Okay, thank you.
Yeah.